Let's take a look at problem 6. So it wanted you to play around with this applet and discover things about quadrilaterals. So part A says, record your observations about parallelograms. Well, what I observed was that opposite sides are equal and parallel, and that opposite angles are equal. So what do I mean by opposite? Well, if you have a quadrilateral, so these two sides would be parallel and equal. So parallel, we draw the little arrows to show that they're equal. We do the hashtag thing, hash marks. Okay, and then this side and this side are equal, and they are also parallel. Okay, so that's what I mean by opposite sides are equal and parallel, and then opposite angles are equal. So this side, or I'm sorry, this angle is opposite this angle, so they're equal. And this angle is opposite this angle, and so they're equal. Part B, record your observations about squares. What seems to be true about all squares? Well, we know all four sides are equal, so two pairs of parallel sides, and all four angles are equal, they're 90 degrees. Their diagonals are equal and intersect at 90 degrees. So that's what I noticed. Part C, record your observations about rectangles. What seems to be true about all rectangles? So opposite sides are equal and parallel. All four angles are 90 degrees. And their diagonals are equal. Okay, part D. Record your observations about rhombuses. What seems to be true about all rhombuses? Well, all four sides are equal, and they have two pairs of parallel sides. Opposite angles are equal, just like with our parallelogram. And then diagonals intersect at 90 degrees. So, what are your observations about trapezoids? What seems to be true about all trapezoids? You have one pair of parallel sides. Well, that's what I came up with. Did you come up with anything else? Okay, let's do one more thing. Let's construct a Venn diagram where the universal set is the quadrilaterals. Remember we did a Venn diagram where the universal set was triangles? So now we're going to do the same thing but with quadrilaterals. So we draw like the table. I like to think of it as a table. And we're going to put all the quadrilaterals that were ever thought of on this table. Inside, we're going to have subsets that are rectangles, rhombuses, trapezoids, parallelograms, and squares. Instead of doing them all at once, let's break this down. Let's draw a Venn diagram with rectangles, rhombuses, and squares. So, why don't you put the sets in there dealing with rectangles, rhombuses, and squares. Pause the video and then come on back when you're ready. Welcome back. Were you able to find a diagram with rectangles, rhombuses, and squares? So we have to think about how they're related. Well, we know every single square there is also a rectangle. And every single square there is also a rhombus. So all the squares are going to fit in both the rectangle and the rhombus oval. So if we have a rectangle oval, a oval for all the rhombuses, then we know the squares are going to be in the middle. So that's the overlap, is the squares. So rectangles are all over here, rhombuses are all over here, and the shapes that are both a rectangle and a rhombus we call a square. Okay, so there's those three. So the two that we have left are the trapezoids and the parallelograms. So pause the video, see how trapezoids and parallelograms play along with the rectangles, squares, and rhombuses, and see if you can draw their sets somehow. And then come on back. Welcome back. Let's take a look at parallelograms first. So parallelograms, opposite sides are parallel and equal, opposite angles are parallel and equal. So if we look at all the rectangles, any rectangle there is meets that definition. So any rectangle is a parallelogram. And same thing with any rhombus. So any rhombus that we could think of, is also a parallelogram. So all the parallelograms are going to include all of these shapes, but then some more. So this is going to be our set of parallelograms. So that leaves trapezoids. Well, do trapezoids and parallelograms and rectangles and rhombuses and squares have anything in common? Not really. Trapezoids are going to be over here and in an entire set all to themselves. Okay, so there you have it. Please take a look at the homework, and I will see you on Tuesday. So the homework is problems 1 through 8 and the homework 3 set. Have a good weekend.